Welcome to online lecture series on Laplace transforms. This is lecture number 11. In this lecture, we will see one of the important property of Laplace transforms, division by t. So what does this theorem state? If L of f of t is equals to f bar of s, then L of f of t by t is given by integral s to infinity f bar of s ds. That is integral s to infinity L of f of t ds. So using this property, we can easily find Laplace transform of f of t by t when we know the Laplace transform of f of t. So before applying this property to find Laplace transform of some functions, first let us prove this property. This property holds when this integral exists. So this proof goes like this. We are given that L of f of t is equals to f bar of s, which means that f bar of s is integral 0 to infinity e power minus st into f of t dt. This is definition of Laplace transform. Now what do? Is we integrate both sides with respect to s within the limits s to infinity. So upon integrating both sides, we get integral s to infinity f bar of s ds is equals to integral s to infinity L of f of t ds, which is equals to integral s to infinity integral 0 to infinity e power minus st into f of t dt ds, because this is the right hand side and we are integrating this again with respect to s within the limits s to infinity. So here we get integral s to infinity integral 0 to infinity e power minus st into f of t dt ds. So here if you observe, the inner integral is with respect to t and the outer integral is with respect to s, and look at the limits. T is from 0 to infinity and s is from s to infinity. So the limits are independent of each other variable. That is, the limits of t are not dependent on s and the limits of s are not dependent on t. So now we can easily change the order of integration in that case. So if the variables are independent of each other, changing the order of integration is just changing the position of the integrals. Outer integral as inner integral and inner integral as outer integral. So if we change the order of integration, we get the right hand side is integral 0 to s, integral s to infinity e power minus st f of t ds. That is, inner integral is with respect to s and outer integral is with respect to t. So this is because the s and t are independent variables. So just we change the positions of the integrals. Now because the inner integral is with respect to s, we can take this f of t outside this integral. So that we get integral s to infinity f bar of s ds is equals to integral 0 to infinity f of t into integral s to infinity e power minus st ds dt. So now if we integrate e power minus st with respect to s, what do we get? Integral of e power minus st is e power minus st divided by minus t within the limits s to infinity. So this is integral 0 to infinity f of t into e power minus st by minus t with the limits s to infinity dt. Now if we substitute the limits, we get integral 0 to infinity f of t into upper limit is here infinity. So e power minus infinity becomes 0 minus lower limit is s. So s is s here. So that we get e power minus st by minus t. This minus and minus becomes plus. Therefore, this gives integral 0 to infinity f of t into e power minus st by t dt. This can be rewritten as integral 0 to infinity e power minus st into f of t by t dt. Now look at this integral. Integral 0 to infinity e power minus st into this function into dt of dt. So what does this this integral give us? This is Laplace transform of f of t by t, because L of f of t is integral 0 to infinity e power minus st into f of t dt. Here in place of f of t we have f of t by t. Therefore, this is Laplace transform of f of t by t. So, finally, we proved that integral s to infinity f bar of s ds is equals to integral s to infinity L of f of t ds is L of f of t by t. So, to conclude, we can write as L of f of t by t is equals to integral s to infinity L of f of t ds. So, to find Laplace transform of f of t by t, it is enough if we find Laplace transform of f of t and we integrate that Laplace transform with respect to s within the limits s to infinity. Okay. So, now let us apply this property to evaluate Laplace transform of some functions. First problem is evaluate L of sine t by t. So, let us write the property again here. L of f of t by t is equals to integral s to infinity L of f of t ds. Now, if we apply this property to this function, we get L of sine t by t is equals to L of sine t, integral s to infinity L of sine t ds. What is L of sine t? It is 1 by s square plus 1. Therefore, this is integral s to infinity 1 by s square plus 1 ds. Integral of 1 by s square plus 1 is tan inverse of s, because we have integral of 1 by x square plus a square dx is 1 by a times tan inverse of x by a. And because here a is 1, we get 1 by 1 tan inverse of s by 1, that is tan inverse of s within the limits s to infinity. So, if we substitute limits, we get tan inverse infinity minus tan inverse s. What is tan inverse infinity? When does, at what angle tan becomes infinity? At pi by 2. Therefore, tan inverse infinity is pi by 2 minus tan inverse s. And pi by 2 minus tan inverse s can be written as cot inverse s, because we have a property that tan inverse x plus cot inverse x is equals to pi by 2. Therefore, pi by 2 minus tan inverse s can be written as cot inverse s. Therefore, L of sine t by t is equals to cot inverse s. Evaluate L of e power minus at minus e power minus bt by t. So, again we apply the same property. L of f of t by t is equal to integral s to infinity L of f of t ds. Now, in place of f of t, here we take e power minus at minus e power minus bt. Therefore, we can write L of e power minus at minus e power minus bt by t as integral s to infinity L of e power minus at minus L of e power minus bt ds. So, first we will evaluate L of e power minus at minus e power minus bt. We know that L of e power minus at is 1 by s plus a. Therefore, this is integral s to infinity 1 by s plus a minus L of e power minus bt is 1 by s plus b ds. Now, we have to integrate 1 by s plus a minus 1 by s plus b. What is integral of 1 by s plus a? It is log of s plus a, because integral of 1 by ax plus b is 1 by a times log of ax plus b. And here, of course, this a is 1. Similarly, integral of 1 by s plus b is log of s plus b. Now, when we have these logarithmic terms and infinity as one of the limit, we cannot directly apply the limit. What happens if we directly apply this upper limit infinity here? Infinity is upper limit. So, if we directly apply here, we get log infinity minus log infinity, which is not defined. But we can further simplify this term and then we can apply the upper limit infinity. We cannot directly apply upper limit infinity here, because that gives an undefined quantity. So, you should observe this point here. So, log s plus a minus log s plus b can be written as log of s plus a by s plus b, because log a minus log b is log of a by b within the limits s to infinity. And this can be written as log of 1 plus a by s by 1 plus b by s. What did we do here? We divided this quantity s plus a by s plus b by highest power of s. We divided the numerator and denominator with highest power of s, that is s. So, dividing s plus a by s, we get 1 plus a by s. Similarly, dividing s plus b with s, we get 1 plus b by s. Now if we apply upper limit infinity, 1 by infinity here, because we have 1 by s here, and 1 by infinity goes to 0. Therefore, this term becomes 0. Similarly, in the denominator also b by s becomes 0. So now we can apply the limits. So now applying upper limit infinity, log of 1 plus a by infinity, that is 1 plus 0, by 1 plus b by infinity, that is 0, minus, and lower limit is anyhow yes. Lower limit is yes. So in place of yes, again we just write yes. So the first term gives log 1. What is log 1? This is log 1. What is log 1 value? It is 0. And here if we take s LCM again, we get log 1 minus, taking s LCM in the second term, log of s plus a by s plus b by s, and that s cancels and we'll have log of s plus a by s plus b. And log 1 is 0 minus log of s plus a by s plus b. That is minus times log of s plus a by s plus b, and this minus can be taken to the power, because m into log a is equals to log of a power m, and s plus a by s plus b whole power minus 1 becomes log of s plus b by s plus a. Therefore, Laplace transform of e power minus at minus e power minus bt by t is equals to log of s plus b by s plus a. Here we have this problem, evaluate L of sine 3t into cos t by t. So again the same property, L of f of t by t is equals to integral s to infinity L of f of t ds. So in place of f of t, here we have sine 3t into cos t. Therefore L of sine 3t into cos t by t is equals to integral s to infinity L of sine 3t cos t. But to evaluate L of sine 3t cos t, we should first multiply and divide with 2 and apply 2 sine a cos b formula. So first let us multiply and divide the right hand side with 2. So that it gives 1 by 2 times integral s to infinity L of 2 sine 3t cos t ds. And 2 sine a cos b is sine a plus b plus sine a minus b. That is sine 4t plus sine 2t. Now L of sine 4t is s by s square plus 16, and L of sine 2t is 4 by s square plus 16 plus L of sine 2t is 2 by s square plus 4 ds. Now integral of 1 by s square plus 16 is 1 by 4 times tan inverse of s by 4, and the 4 gets cancelled here. Similarly, integral of 1 by s square plus 4 is 1 by 2 times tan inverse of s by 2, 2 gets cancelled. So we have tan inverse of s by 4 plus tan inverse of s by 2. Now if we apply the limits, we get 1 by 2 times tan inverse infinity plus tan inverse infinity, that is upper limit, minus lower limit is s. So again we get the same term, tan inverse s by 4 plus tan inverse s by 2. This can be written as 1 by 2 terms, tan inverse infinity is pi by 2 plus pi by 2 minus tan inverse s by 4 plus tan inverse s by 2, and this can be written as pi by 2 minus tan inverse s by 4 plus pi by 2, again second pi by 2 minus tan inverse of s by 2. And pi by 2 minus tan inverse s by 4 is cot inverse s by 4. Pi by 2 minus tan inverse s by 2 is cot inverse of s by 2. So finally we obtain 1 by 2 times cot inverse s by 4 plus cot inverse s by 2. So hope you understood this problem. Now practice these questions. Do practice the questions. Don't skip them, because if you can solve these problems by yourself, that gives you more confidence rather than watching the solved problems or learning the solved problems. So here you have a few questions, 3 questions I think. Evaluate L of cos 2t minus cos 3t by t, L of 1 minus e power t by t, L of cos 4t into sin 2t by t. So you just apply the formula directly. L of f of t by t is equals to integral s to infinity L of f of t ds. Upon evaluating the integral, you obtain the answer. Thank you for watching this video. Keep learning.